Most people think of sunflowers as simple plants: bright yellow petals, tall stems, seeds for birds. But if you spend enough time watching a sunflower patch closely, you begin noticing something much more complicated happening, especially if bees are involved. One of the first things many people notice is that bees do not visit sunflowers randomly. They often move in repeated loops, returning to the same flowers day after day, as though they are following remembered routes through the garden. And in a way, they are. What most people think of as the flower in the center of a sunflower is not actually one flower at all. The dark center is made of hundreds or even thousands of tiny individual flowers called florets. These florets do not all open at once. Instead, they bloom gradually in rings, usually moving from the outside inward. Every day, a new circular band opens across the sunflower head. That means fresh pollen appears daily, fresh nectar becomes available, and pollinators return repeatedly to check for new blooms. To a bee, the sunflower is not a one-time meal. It is a slowly refilling food station. This blooming strategy benefits both the plant and the pollinators visiting it. If all the florets opened at once, the sunflower would exhaust itself quickly, and the useful flowering period would end much sooner. By staggering the bloom over many days, the sunflower extends pollinator visitation and increases the chances of successful pollination over time. One sunflower head can feed insects for days or even weeks. That is why bees often appear to do laps around sunflower patches. They are checking which florets opened overnight, where fresh pollen is available, and which flowers still contain nectar. And bees are remarkably good at remembering productive food sources. If you look closely at the center of a sunflower, you may also notice spiral patterns. These spirals often follow mathematical growth patterns found throughout nature, including Fibonacci sequences and other highly efficient packing structures. The arrangement allows maximum seed density, efficient sunlight exposure, and easier pollinator movement across the flower head. The structure of the sunflower and the behavior of the bee fit together almost perfectly. Sunflowers also provide more than nectar and pollen. Their large, dark centers absorb warmth from sunlight, especially during cool mornings. For pollinators trying to raise their body temperature enough to fly efficiently, this creates a warm landing platform filled with food. To a bee, a sunflower is not simply a flower. It is food, warmth, navigation, landing infrastructure, and eventually a future seed source. And the relationship between sunflowers and pollinators continues long after the blooming season ends. By autumn, the petals dry and fall away. The once living stems become tall brown stalks standing through the snow. Many people see this stage and assume the plants are dead or useless. But the ecosystem is still using them. The dried sunflower stalks and hollow stems become overwintering habitat for many native insects, including certain species of bees. Unlike honeybees, many native bees are solitary. They do not live in large managed colonies. Instead, some species lay eggs inside hollow stems, tunnel into soft, pithy plant material, or use abandoned cavities in dead vegetation. To these insects, a dead sunflower stalk is not garbage, it is shelter. Some native bees lay eggs inside stem cavities and seal the chambers using mud, leaf pieces, plant fibers, or resin. The larvae remain protected inside throughout winter until temperatures warm again in spring. Other insects also rely on standing dead vegetation: butterflies, moths, beetles, spiders, beneficial wasps, and small animals seeking cover during cold weather. Even snow behaves differently around standing plants, creating tiny insulated pockets that help protect life beneath them. This is one reason many pollinator conservation groups now encourage people to leave stems standing through winter and into spring. Aggressively cleaning gardens in autumn can accidentally destroy overwintering chambers and remove important habitat before insects have emerged. A perfectly tidy yard often supports surprisingly little life, but a slightly messy yard, filled with standing stems, seed heads, native flowers, and undisturbed corners, can support entire layers of an ecosystem. And this is how prairie systems naturally evolved. In grasslands and wildflower meadows, plants are not removed at the end of each growing season. Stems persist through winter, seeds feed birds, hollow stalks shelter insects, snow gathers differently around vegetation. Then spring arrives and the cycle begins again. One sunflower patch can support life in stages throughout the entire year. In summer, nectar and pollen feed pollinators. In autumn, seeds feed birds and wildlife. In winter, stems become shelter and overwintering habitat. And in spring, new seedlings emerge while dormant insects wake inside last year's plants. The entire system continues turning quietly beneath the surface. And honestly, this is the part many people miss. Most people move too quickly through the landscape to notice these small relationships happening around them. But once you slow down enough to watch bees making daily inspection laps through a sunflower patch, or notice birds feeding on dried seed heads in winter, the garden stops feeling decorative. It starts feeling alive. You begin realizing the bees are not wandering randomly, the plants are not passive, and the dead stems are not empty. Everything is participating in something larger. A sunflower is not just a flower. It is part of an ongoing relationship between insects, birds, seasons, weather, soil, and time itself. And sometimes all it takes to notice that relationship is standing quietly in a sunflower patch long enough for the bees to teach you how it works.